Okay, so I'm going to talk about this paper called Test Optional Policies, Overcoming Strategic Behavior and Informational Gaps. I'm Zhi Liu from Cornell University, and this is joint work with my advisor, Nikhil Garg. So just for a quick background history, dropping standardized testing requirement is not a new thing. For example, Bowdoin College has been doing it ever since the 1960s. Due to the COVID pandemic, however, a lot of universities are swarming in to embrace this kind of policies. For example, Harvard decided they're going to do it last year. Kind of motivated by this, the NACAC, which stands for National Association for College Admission Counseling, which is an organization of college admissions professionals, they gathered these pledges from many of the prestigious universities in the US, saying that they will not penalize students for the absence of a standardized test score. Despite those strong claims, some private tutoring firms are still claiming that test optional is not really test optional. So over the years, we have seen many empirical work on test optional policies. They all identify some kind of potential problems with these kind of policies. For example, bimodal income distribution among non-submitters and higher enrollment rate among the admitted non-submitters. Third, they observe drastically increased average reported SAT score when the college embraces test optional policies. So there are also a number of very good theoretical work on these test optional policies, but our work differs both in the setting and in the research questions. So we're going back to the university's claims of not penalizing students. In this paper, we suppose that test scores are not required, which is the reality with a large number of colleges in the US. We also suppose that students are required to submit multiple features besides test scores. This is also a reality in college application. So students are required to submit their high school transcripts and letters of recommendations, etc. Under this setting, we study these two research questions. The first is that what does not penalize students mean in this setting? The second is that what are the challenges to meet it and how do we overcome them? Our contributions are also twofold. So to the first question, we formalized notions of fairness under a serialized model. To the second question, we identified the first key challenge to be strategic behavior of students with test access, and we proposed a strategy-proof approach to solve this. We identified the second key challenge to be an informational gap between students who submit scores and the students who don't submit scores. And we proposed a resampling procedure to solve this in a stochastic way. Okay, and this is our model. So our model actually extends that of the authors of the previous talk, such that the test score can be optionally submitted. We also assume that students have a true skill, which is unobserved. We divide students up into two groups based on their access to tests. Just one thing to note here is that the true skill distribution is still identical across those two groups of students. So students without access to tests, they are required to submit K-1 features, which are noisy measurement of their true skill to the university. However, the students who have access to tests, they have two options. They can either submit their test score, or they can hide their test score and pretending they don't have access. So in this case, they only submit the K-1 features, just like the students from the other group. And they make this decision based on the objective of getting a higher estimated skill. So we also consider the case in the that students strategize on taking the test rather than submitting the score. And in the paper, we find that all the results basically hold. So how do the school do the estimation? Well, the school does, we denote by FP the school's estimation policy, estimation function under a given policy P. So this function will use all available information about the student, which includes the features that the student have submitted, as well as whether the student submits a score. So this this decision from the student. And the school uses all those information to inform its estimation. We denote by X as the student's decision function. So this decision function actually depends on all of the student's features as well as the school's policy. So the assumption that X depends on the policy is actually crucial because the students need to know this in order to maximize their estimated skill. So in this illustration of our model, intuitively, we can see there are two places where things could go wrong. First is that, so students with test access can strategically choose whether to submit the score or not, which we see there's potential for strategic behavior. The other thing is that when the school is doing estimation, it potentially have differential amounts of information from different groups of people, which will cause an informational gap between different students. So from the modeling section, we see that the estimation function FP and the decision function X actually have impact on each other. So it's imperative for us to define an equilibrium. So we suppose all decisions are feasible to the students, then the decision function X and the estimation function FP constitute an equilibrium if given the estimation function. Every student with test access will weakly prefer her current course of action, which means that she will not deviate from whether submitting or not submitting. And given X, the decision function, the school follows the information given in this function to make estimation, which is basically the definition of how the school does estimation. After we have defined the equilibrium, to answer the first question, we defined the following fairness criteria. It would be a bit time-consuming to go over all of them, so that for the moment, let's focus on the second one, which we call observable fairness. So we say that a policy P is observably fair if in every equilibrium, for all the required features, for all the observable features, the Q tilde, the skill estimate, given those required features, is the same across two access groups. So intuitively, what this is essentially saying is that given the features that are available to all the students, whether the student have access or not will not affect how her skill estimate comes. And the reason why we define different levels of fairness criteria is because we found that they offer different levels of stringency, and we found that under different scenarios, different fairness criteria are likely to hold. So first, for the situation that is most akin to what's in reality, is that we ask what will happen if school does not know who has access and who does not. In this theorem, we were able to show that when the school does not know the true access status and uses the optimal Bayesian manner of estimation on all of the students, then for every set of those required features, there exists a threshold score, such that for a student with test access, if she's got a score above that threshold, she will report the score, and otherwise she will not report the score. Furthermore, we were able to show that none of the fairness criteria are satisfied in this situation. So let us recall that an empirical work pointed out that when embracing test optional policies, colleges saw an increased average reported SAT score, which this theorem helps explain. Furthermore, to show that when the school does not know access, it fails miserably, we showed that if the school does not know access, then any attempt to make the estimation policy either observably or latent skill fair will result in the policy ignoring the test score altogether. So this means that when the school does not know true access, really there is no good solution here. And the natural question to ask at this point would be, would it help if school gains the knowledge of students' test access? For example, the school can do so by requiring an attestation of lack of access. Now, the good thing, well, the lucky thing is that it does help. So in this lemma, we showed that suppose the school knows access status and still use optimal Bayesian estimation on all of the students, then the unique equilibrium is one in which all students with test access will submit the score. This is a good thing because we have eliminated strategic behavior because, well, in this case, we know what the students will be doing. However, we still have informational gaps to consider. Let us recall the definition of observably fair, which says that the skill estimate given the observable features is the same across two access groups. However, in this situation, the students who don't have access, their skill estimate is going to be a fixed number because the observable features are all of the information that school has on them. However, for the students who have access, their skill estimate given the observable features is still a random number because they are awaiting their random test score. To give more intuition behind this, I would like to draw on Phaedra's talk. So this is kind of what differential informativeness is working at this situation. So how to mitigate this? We proposed a resampling policy. So consider this policy. For students with access, we still use Bayesian optimal estimation. However, for students without access, we will resample a test score based on the observed features. We will add this to her profile and we use Bayesian estimation. We were able to show that when school knows access status, then this resampling policy is both observably and demographically fair. So the idea is that we're using a sampling procedure to overcome informational gaps stochastically. So this is still a group level fairness, but we were able to overcome these informational gaps. Just to quickly wrap up my talk, our contributions is twofold. So first, we formalize notions of fairness in test optional setting under a very stylized model. The second is that we identified two key challenges to fairness in this setting, and we proposed our solutions. We believe that our work has some policy implications, so we provided an upper bound on the impact of knowledge on test access that may be beneficial to the colleges and universities. We also laid down some guidelines for what policies are actually likely to be effective. However, development of really workable schemes in practice still require considerable work alongside college admissions practitioners. So in this work, we were also able to identify a more general setting, which is that the strategic behavior of some agents in the system introduces inequities that must be countered. Now, we believe this is a setting that arises in many social systems, and it's surprisingly less studied in the literature, which we think would be a good thing to study. Okay, so that's the end of my talk, and I'm happy to take questions here or offline.
Anna, do you want to? So Anna is asking whether the sampling procedure for overcoming information gaps, whether it's done online.
Yeah, that's a very good question. So for this setting, we're basically considering a continuum of students that are kind of static in the sense that their skill and their features are kind of fixed. So it's very convenient for a modeling and a theoretical framework. So it might not be what really happens in practice, and this we must admit that it needs some work with the college practitioners. So so at this time, it does not support incoming students in a rolling way. We're just doing this estimation based on individual students, and we don't take any information from other students.
So Andrea is asking a question. I wonder rather than, whether instead of using OLS, whether you thought of using the structure of the model that is directly estimating the parameters of the distribution.
I think that question was for Phaedra's talk.
Yeah, sorry.
Okay, I'm sorry.
Yeah, I'll reply.
And then Adam is asking you, well, he's first acknowledging great work and then clarifying, asking whether colleges are strategic and whether you'd consider different policies and their fairness properties, which one is optimal from the college perspective.
Yeah, so the reason that we actually define different levels of fairness is that we don't know which one is optimal for the college. So we're just laying these fairness criteria that that would be kind of for the colleges to decide which one of them meets their objectives more. So basically, the three levels of fairness, each one is more stringent than the other one. And we were able to identify that at the best case, only observable fairness will hold. And so the latent skill fairness does not hold.